All right, so this is Spencer and Brady, lesson 9, group problems. I'm going to go ahead and get us started. I'm just going to screen share my work real quick. All right, so number 1 is just asking us to draw a picture of an intermediate stage of DNA replication and tells us what we need to include in there. So just to start, we have our 2 replication forks, 5' to 3', and then the complementary strand running the opposite, 5 to 3. We have our DNA helicase that is unzipping the genes right here. And then we have our leading strands. And then we have our lagging strands, or our Okazaki fragments right here that are behind the leading strand. And then right here, we have our ORICs, our origins of replication. We have these little reddish orange. These are RNA primers. And we have this little blue square kind of, and that's our DNA primase. So that's all that's doing is basically just synthesizing RNA sequences. And we have our DNA polymerase 3, and that's just kind of like proofreading and it's doing its thing over there. All right, now I'm gonna go ahead and switch over and turn it over to Brady so he can do 2 and 3.
Okay, I'm doing 2 and 3, and my roommates have the music blasting, so sorry if you guys can hear it. But so number 1 for number 2 is DNA primase. B for number 2 is DNA A. C is epsilon. D is DNA polymerase epsilon. E is TUS or TUS, or however you want to say it. I feel weird saying TUS, so I just say TUS. Number F is DNA polymerase 1. G is DNA gyrase. H is ORC. Maybe that's supposed to be ORIC. Spencer, what is that supposed to be?
It's ORC. You're good.
Okay, ORC, I'm good. I is SSBP, and J is DNA ligase. So now on to question 3. It says list 5 enzymes, prokaryotic and eukaryotic, that consume ATP during DNA replication. So we're going to have helicase, primase, gyrase, ligase, and DNA A. So I think that's all 5 that I named. B says list 5 enzymes, prokaryotic and eukaryotic, that consume DATP during DNA replication. So we're going to have DNA polymerase 1 and 3. We're going to have alpha, delta, and epsilon also. 5 enzymes, prokaryotic and eukaryotic, that have 3 to 5' exonuclease activity. You're going to have DNA polymerase 1, 2, and 3, along with epsilon and delta. And D says indicate 1 enzyme, prokaryotic or eukaryotic, involved in replication that uses DNA as a template to synthesize RNA. And I put DNA primase. So now back to Spencer. Oh, nope, sorry, I have an E also. It's tucked on the next page. It says indicate 1 enzyme, prokaryotic or eukaryotic, that uses RNA as a template to synthesize DNA, which is telomerase, or however you want to pronounce that. Sorry if it's pronounced wrong.
Brady's about to get surgery. He's a little loopy right now. All right, so back to me. So I'm going to pick up at number 4. And this is the one that Sister Mayo did a video for. Pretty easy once you watch it, if you watch it. And so basically what we start with is we have this single-stranded DNA molecule, and it gives us this 5', 3'. And then we have our primer right here. And so basically we know that the primer is going to run opposite or complementary. So it's going to be 5' to 3'. And we know that it's lining up this way because if you can see it right there, it's ATCGGCAT. So it matches up. So basically for A, it's saying the nucleotides in this reaction include all these. And so basically we're not going to, I guess, it's not going to cancel out. And so what's going to happen is we're going to pick up off of the primer at T, and then we're just going to run all the way back down to this 5', and you're just going to give the complementary nucleotide. And so that's where we get right here, this ACT TG, AT, GG, and so on. And so just like I have right here in parentheses, you just start where the primer left off. For B, basically we're looking for the different one, and what we find here is we have D, C, and P. And so what that means is that there's going to be no C, so it's going to end there. So if we start back where the primer left off, we have A, and then we have a guanine, but to complement that, we need a cytosine or the C, and we know that there's going to be no C in this, so it's just going to be 5' A, 3', and that's it. In C, we know that the different one is this one. We just have UTP, which means that there's going to be no T or thymine. And so once again, we're going to start where the primer left off, and we're going to have A, C, and then we need our thymine right here to complement the adenine. And since we don't have that, we just have our answer is 5' AC 3'. And then for D, the different one is GTP. And so we know that there's going to be no G or guanine. So once again, we're going to start where our primer left off. So we're going to have ACT. And then right here where this C is, we need a G, but we're not going to get it. And so it's going to shut off right here. And so we just get 5' ACT 3'. So that's how we're going to do number 4. And then number 5 is just kind of like a matching. We're just, which of the following? And so for A, which of the above proteins is found in prokaryotes? And so that's DNA gyrase, DNA primase, DNA polymerase 1 and 3 with the alpha subunit, DNA A, and TUS. And then B is asking for what is found in the mouse musculus, and that's EDC6, DNA polymerase epsilon, MCM helicase, DNA primase, DNA polymerase alpha, telomerase, pCNA. E to the above proteins is involved in chromosome compaction, that's DNA gyrase. Proteins is involved in the initiation stage of DNA replication, that's CDC6 and DNA A. E, which of the above proteins is involved in the termination stage of DNA replication, and that is MCM helicase and TUS. And so those are the answers we got. And hopefully those are right. But thanks for watching.
Yeah.